Today, I want you to just close your eyes for a second. Picture this. A car, maybe a sleek EV, just gliding through a busy city street. No driver. It's sensing everything, pedestrians, lights, other cars, perfectly smoothly. You're inside, maybe reading, maybe just relaxing.
That classic sci-fi vision.
Exactly. But here's the thing. It's not really science fiction anymore, is it? This future, it's moved decisively into a real, tangible, and incredibly fast-moving industry.
Yeah, absolutely. And what's really fascinating as you describe it isn't just that it's happening, but how it's happening. It's not like one single race to a finish line.
Right.
It feels more like a complex campaign fought on multiple fronts. You've got different companies making fundamentally different bets, pursuing wildly different strategies.
Billions of dollars, right?
Billions. And countless hours poured into solving what is, arguably one of the toughest engineering and AI challenges ever attempted. It's quite something to watch unfold.
Okay, so let's unpack this. Our mission for you in this deep dive, as always, is to cut through all the hype, all the noise.
Oh, what a noise.
There is. We've gathered a stack of really comprehensive analyses, internal reports, expert forecasts, all on autonomous vehicles. And our job is to pull out the most important nuggets for you, the insights you won't just find skimming headlines.
Think of it as your shortcut, a way to get truly well-informed on who the key players are, the tech paths they're gambling on, and how they're positioning themselves in this race.
And for part one today, we're laser-focused on the companies and their strategies. We want to explore how you even determine leadership in this space. It's not just about miles driven, right?
No, not at all. We need to dig into the fundamental technology choices they're making, that architectural foundation. We need to look at how vertically integrated they are, how much they build versus buy.
And crucially, the paths they see to actually making money, to scalable commercialization.
Exactly.
So here's where it gets really interesting, I think. We're going to dissect the main competitors. We'll compare their tech stacks, their strategies, try to pinpoint who's leading in which part of the market.
And we have to talk about this fundamental architectural divide. It's a deep philosophical split that's really shaping the entire future of the industry. It's bifurcating things.
Okay, so if you're ready to get that shortcut, to really understand the race for autonomy, let's dive in. All right, let's jump straight into that core divide you mentioned, this philosophical, technical split that seems to underpin everything else.
It really does. It's the bedrock.
On one side, you have what we're calling the more is more philosophy. What's that all about?
Well, essentially, it's the belief that for true safety and reliability, especially in really complex places like cities, you need the absolute most comprehensive sensor suite you can get. Redundancy is key.
So lots of different types of sensors.
Exactly. A rich mix LiDAR, which uses lasers to map the world in 3D, radar, which is great in bad weather, and high-resolution cameras. The idea is each sensor type makes up for the weaknesses of the others.
Like a safety net built from different materials.
Precisely. And just as crucial, this approach leans very heavily on having incredibly detailed, pre-existing high-definition maps of the areas where the cars will operate.
So they know the environment before they even start driving.
Right. It's about giving the car every possible advantage, every bit of data, building certainty through redundancy and a prior knowledge. Maximize information, maximize safety.
Okay, that sounds logical. But then there's the other side, the human analog AI approach. That sounds different.
It's fundamentally different. This side champions generalized AI. The core belief is that with enough data, like truly massive amounts of data, and powerful enough neural networks, an AI can learn to drive just like a human, or maybe even better.
Using simpler hardware.
Generally, yes. Primarily relying on cameras, much like human eyes. The goal isn't just to follow rules, but to replicate and eventually surpass human perception and decision-making.
So it's more about learning general driving intelligence.
Exactly. The hope is this makes the system highly adaptable to new situations, new places, without needing those super detailed maps beforehand. It's potentially much more scalable.
So this isn't just, a minor technical preference. This disagreement shapes everything, doesn't it? R&D, deployment, business models.
Absolutely everything. It creates distinct strengths for each side, but also very distinct vulnerabilities. It is the foundational debate right now. It dictates who's doing what, how fast they can move, and how much it all costs.
Okay, so to really get a handle on this, we need to look at the companies putting these philosophies into practice, the ones building the full self-driving systems. Where do we start?
I think we have to start with Waymo. They're the methodical pioneer and currently the undisputed leader in actually deploying commercial level 4 robotaxis.
Waymo. Spun out of Google's self-driving car project. what, over a decade ago now?
Yeah, it's been a long journey for them.
And they've had this incredibly consistent mission, haven't they, to build the world's most experienced driver. Their whole approach feels very safety first, deliberate, methodical.
And initially very geofenced. They're aiming squarely at SAE Level 4 autonomous ride-hailing.
Let's just clarify level 4 for everyone. That means the car does all the driving within certain conditions, right? A specific area, good weather, that kind of thing. No human needed.
Correct. The human is purely a passenger in that operational domain.
So Waymo's tech stack, this is the poster child for more is more, isn't it?
Absolutely. If you look at their current vehicles, often those Jaguar I-Pace SUVs you see, they are just bristling with sensors. It's not a few cameras.
No.
No, we're talking multiple types of LiDAR, long-range ones looking far ahead, short-range perimeter ones giving a dense 360-degree bubble around the car.
Good.
Then there's a suite of cameras, something like 29 high-resolution cameras positioned all around.
29, wow.
And on top of that, several radar units as well. It's a formidable array.
And the key here, I guess, isn't just the number, but the diversity, the whole redundancy thing.
That's the core idea, the belt and suspenders approach. Think about driving in heavy fog or torrential rain. Cameras struggle, right? They need visible light. Even some LiDAR can have issues with scattering.
Makes sense.
That's where radar shines. It cuts right through that weather, detecting objects, maybe not with pinpoint precision, but it sees them.
Okay.
Conversely, LiDAR gives you that incredibly precise 3D map of the world, depth perception that cameras alone can't match, especially at night, or with weird shadows or complex shapes.
So each one covers the other's weaknesses.
Exactly. It ensures reliability. They fuse all this data together to get a multi-layered 360-degree view, stretching out, they say, up to 300 meters. It's about building a complete, resilient picture, regardless of the conditions, like having multiple sets of eyes, seeing different things, feeding one brain.
And their software and mapping, it's not just sensors.
No, definitely not. Waymo is critically dependent on creating and maintaining these incredibly detailed, custom 3D maps of their service areas before they deploy.
The HD maps we hear about.
Yes. These aren't like Google Maps on your phone. They contain incredibly rich information, precise lane markings, curb heights, traffic sign locations, even the geometry of complex intersections. Everything's static.
And the car uses its sensors to place itself on that map.
With centimeter-level accuracy, it uses the real-time sensor data to figure out exactly where it is within that pre-mapped world.
What's the benefit of doing it that way?
It hugely reduces the real-time computational load for understanding the static parts of the world. The map already tells the car where the lanes are, where the curbs are.
Right, so the car's brain can focus on the tricky stuff.
Exactly. It allows the system to dedicate more processing power to perceiving and predicting the dynamic actors, other cars, pedestrians, cyclists, construction zones, the unpredictable elements.
And the software itself is complex.
Highly. It's a modular architecture. Sophisticated systems for perception, prediction. They use advanced models like VectorNet and Scene Transformer to try and figure out what other road users might do next, then planning the car's path, and finally, controlling the vehicle smoothly and precisely. It's very refined.
They must do a ton of testing.
Oh, absolutely. Simulation is a cornerstone for them. They have this platform called CarCraft.
CarCraft.
Yeah. And the scale is mind-boggling. They've logged over 20 billion miles in simulation.
Billion, with a B.
Billion, compared to maybe 20 million miles on real-world roads.
That's a huge difference. Why so much simulation?
It allows for incredibly rapid iteration. You can test software changes instantly, but more importantly, it lets them safely and repeatedly test thousands of those rare, dangerous edge case scenarios.
Stuff that rarely happens in real life.
Exactly, like a weird multi-car pileup or an emergency vehicle coming the wrong way or a sudden sinkhole appearing. Things you might only see once in a million miles or things too dangerous to test repeatedly on public streets. CarCraft builds that experience virtually.
Okay, so theory and simulation are one thing. What about actual deployment?
This is where Waymo is the clear leader for Level 4 robotaxis. Their Waymo One service is fully operational, taking paying customers in places like Phoenix, San Francisco, LA, Austin.
And they're doing significant numbers of rides.
Reportedly over 250,000 paid trips per week across those cities now. That's real scale. And they're planning to expand to Atlanta, Miami, other places.
I saw they partnered with Uber, too.
Yeah, really smart strategic move. They're integrating Waymo vehicles onto the Uber app in some cities. It gives them instant access to a huge customer base and network demand. Waymo doesn't have to spend years and millions building its own ride-hailing brand awareness from scratch. It boosts ridership immediately.
So Waymo's strategy seems very thorough, very safety-focused. Control the environment with maps and geofences.
It definitely reduces the complexity of the problem, but there's a catch, right?
Always a catch.
It's slower to expand. That mapping process is intensive and expensive, and the cars themselves, loaded with all those sensors, are very costly.
So the business side is challenging.
It requires very high utilization rates. You need those expensive cars running almost constantly in dense urban areas to make the economics work, which is precisely why that Uber partnership is so crucial. Get more rides, justify the cost. It's a deliberate, high-cost, high-reliability bet.
Okay, so Waymo is the careful giant, mapping everything meticulously.
Yeah.
Then there's Tesla. Complete opposite end of the spectrum, it feels like.
Almost entirely. Tesla's ambition is, well, huge, audacious, really. They're not just trying to build a self-driving car for certain areas. They're aiming to solve generalized real-world AI for driving everywhere.
Using only cameras.
That's the core of it, a vision-only approach. They leverage their massive global fleet of cars already on the road as this giant data collection machine.
And the end game is?
A decentralized robotaxi network. The idea is, with a software update, millions of existing Tesla cars could become autonomous taxis. It's a massive leap of faith in AI.
It sounds like a huge gamble relying only on cameras. That Tesla Vision system.
It is. They use a suite of 8 external cameras, but they've completely ditched LiDAR. And for a long time, they even ditched radar, though there are signs they might be re-evaluating that slightly.
What's the argument for going vision only? Musk's argument.
Fundamentally, it's that humans navigate with biological eyes, so a sufficiently advanced AI should be able to as well. Adding more sensors, in his view, just adds cost, complexity, and potential points of failure or conflicting data.
But that puts enormous pressure on the software, doesn't it?
Immense pressure. You have to interpret depth, speed, object types, everything, just from 2D camera images. And think about the challenges. Bad weather, heavy rain, snow, fog, low light, direct sun glare.
Situations where LiDAR or radar have natural advantages.
Exactly. So it's a radical departure from the industry consensus, which, as we saw with Waymo, really leans towards that multi-sensor redundancy for safety.
So how does their software work? Full self-driving, FSD.
It's constantly evolving, but the direction is towards what they call a unified end-to-end neural network architecture.
End-to-end, meaning?
Meaning the AI learns to go directly from raw inputs, like the video feeds from the cameras, straight to driving outputs, like steering and acceleration commands. It's less about distinct human-coded modules for perception, planning, etc.
So it learns more like a human. Input to action.
Kind of. The famous example was FSD version 12, which reportedly replaced over 300,000 lines of traditional C++ code explicit rules with a single large neural network trained on millions of video clips of driving.
Wow. That's a fundamental shift.
It is. It promises much greater adaptability and the ability to handle situations the programmers never explicitly coded for. And crucially, unlike Waymo, Tesla does not use pre-built HD maps.
No maps at all. How does it know where it is?
It generates a real-time representation of the world, what they call vector space, directly from the camera feeds. This, theoretically, is key to their scalability. No need for mapping vans. You could potentially switch it on anywhere in the world almost instantly.
That sounds like a huge advantage, if it works.
If it works reliably. And this leads to Tesla's biggest competitive advantage, their secret sauce, really. The data engine.
The fleet.
The fleet. Millions of Teslas on the road worldwide, driving billions of miles in every conceivable condition. It's an unparalleled fire hose of diverse, real-world driving data.
And every time a driver has to intervene.
That's a corrective signal. It tells the AI, you did something wrong here. That data goes back, gets used to retrain the neural networks, making them better. It's this massive continuous learning loop.
Powered by their own chips too, right?
Yes, custom silicon. The FSD chip in the cars for running the AI in real time, and their Dojo supercomputer, which is purpose-built for training these enormous AI models. It's an unmatched data flywheel.
How do they deploy this commercially? It's different from Waymo's robotaxi service.
Very different and quite controversial. They sell what's technically an SAE Level 2 driver assist system. It requires constant driver supervision. You have to keep your hands on the wheel, eyes on the road.
But they call it full self-driving supervised.
Exactly. And that naming has drawn a lot of criticism and regulatory scrutiny. But functionally, selling the system to hundreds of thousands of consumers, over 400,000 in North America alone, acts as a massive ongoing public beta test.
So customers are testing the system in the real world.
Effectively, yes. They've also started a very small, invite-only robotaxi trial in Austin, Texas, using these same consumer cars, not purpose-built ones.
And the long-term vision is that owners let their cars work as taxis.
That's the dream. A decentralized network where your Tesla earns you money while you're not using it. A direct competitor to Uber or Lyft, but using privately owned cars.
So Tesla's approach is clearly about breadth, aiming for pretty good everywhere, rather than perfect in limited zones.
Right. But it's definitely a higher risk, higher reward game. The marketing controversy is persistent. Names like autopilot and FSD are seen by many regulators and safety advocates as misleading, implying more capability than the system actually has.
And there have been high-profile issues. Crashes.
There have been crashes investigated by safety agencies and documented failures in testing, like the system failing to recognize a stopped school bus in one stage test. It highlights the immense difficulty of solving that long tail of rare, unpredictable edge cases.
Especially with just cameras.
Especially with just cameras. The bet is enormous. If their AI-first approach genuinely cracks generalized driving, they could scale globally almost overnight and dominate. But if that final 1%, those really tricky edge cases prove too hard for vision alone,
Then the whole strategy is in trouble.
potentially yes. It's a massive all-or-nothing bet on AI.
Okay, so we have Waymo, the careful planner, and Tesla, the AI gambler. Where did other players fit in, especially those with traditional auto industry backing? Let's talk about Cruise, GM's big play.
Right, Cruise. Their strategy was kind of a hybrid, trying to blend Silicon Valley speed with Detroit manufacturing muscle
What was their goal?
to launch a purpose-built Level 4 robotaxi service, specifically targeting dense, complex cities. Think San Francisco chaos.
And their tech approach. More like Waymo or Tesla.
Definitely closer to Waymo. They firmly believed in the safety through redundancy idea. Their vehicles had a big sensor suite, over 40 sensors, including multiple lidars, radar, cameras, a full 360-degree view. They explicitly rejected the vision-only path.
Did they use HD maps too?
Yes, relied heavily on pre-built HD maps for precise localization within their geo-fenced areas. They really engineered their system for the unpredictable nature of cities like SF.
I remember they had a unique vehicle too, the Origin.
That was a key differentiator. The Cruise Origin, developed with GM and Honda, all electric, no steering wheel, no pedals, just a spacious cabin with inward-facing seats, designed purely for ride-hailing. It really looked futuristic.
Okay, for a while, they seemed like the main competitor to Waymo, right?
Yeah, absolutely. They were the clear number 2 in the robotaxi space. They successfully launched fully driverless commercial services in San Francisco, Phoenix, Austin. They were scaling up.
But then, disaster struck.
Catastrophically derailed. October 2023, there was a very serious incident in San Francisco. One of their AVs struck and then dragged a pedestrian who had first been hit by a human-driven car.
And the fallout was huge.
Massive. There were serious allegations that Cruise withheld crucial video footage and details from regulators. Trust just evaporated overnight.
So what happened to their operations?
Immediate suspension of all driverless permits nationwide, a complete halt to all operations. They're now in a deep rebuilding phase. New leadership, a shift back to supervised testing, trying to slowly, cautiously earn back trust.
It feels like a huge cautionary tale for the whole industry.
The most potent one, probably. It just hammers home that technological capability isn't enough. Public trust and regulatory approval are absolutely paramount.
The move fast and break things mantra doesn't work here.
Not when you're dealing with 2-ton robots on public streets. A single bad incident, especially if handled poorly, can wipe out years of progress and billions in investment. Honestly, Cruise probably only survived because of GM's deep pockets. Without that backing, they likely would have been finished. Trust is the ultimate currency here.
Okay, beyond these big companies trying to build the whole self-driving car, Waymo, Tesla, Cruise, there's another really important group, right? The enablers. The ones providing the tools, the components.
Yeah, the picks and shovels for the autonomous gold rush, as some call them. They supply critical hardware and software, letting the wider auto industry get in the game without building everything from scratch.
And a huge name there is NVIDIA.
Massive. NVIDIA's strategy is distinct but incredibly ambitious. They want to be the foundational AI computing platform for the entire auto industry.
Not just chips.
No, an end-to-end solution. It starts in the data center, where they provide the hardware and software for training these huge AI models, and it extends right into the car with the computers that run those models in real time to make driving decisions.
So what's the core product in the car?
It's their NVIDIA Drive AGX platform. Think of it as the car's AI brain. It's powered by their scalable chips, like Orin, which is widely used now, and the next-gen Thor. This runs on their safety-certified operating system, Drive OS.
And they offer software too.
Yes, they have Drive AV for the autonomous driving functions and Drive 9X for the intelligent cockpit and driver monitoring. It's designed as a comprehensive package for automakers.
But you said it goes beyond the car itself.
Crucially, yes, they offer a whole ecosystem for development, DGX systems for that massive AI training in the cloud, and platforms like Omniverse and Cosmos for creating highly realistic simulations, digital twins of the real world, and generating synthetic sensor data.
Why is that important?
It lets automakers train, test, and validate their AV systems much faster and more safely in the virtual world before hitting the streets. It accelerates development massively.
So what's NVIDIA's game plan here? How do they make money?
It's purely B2B. They're a Tier 1 technology supplier. They sell this platform to a huge range of partners, traditional automakers like Mercedes-Benz, Volvo, JLR, newer players like Rivian, Polestar, even other AV developers like Zoox, Pony.ai.
So they're trying to be the standard platform, like Intel or Android for cars.
That's a great analogy. The Wintel, or Android, of the software-defined vehicle. They provide this powerful, flexible, standardized platform, enabling dozens of companies to build advanced AV features without the colossal cost of developing their own chips and core AI infrastructure.
So NVIDIA wins if the market stays diverse.
Exactly. They supply the compute power for everyone else's innovation. It's a very strategic position.
Okay, who else is a major enabler? Mobileye comes to mind. They've been around a long time.
A very long time. Mobileye, now an Intel company, has taken a more evolutionary path. They've leveraged decades of leadership in computer vision for cars, specifically in ADAS advanced driver assistance systems.
The safety features we have now? Like
Yeah.
emergency braking.
Exactly. Their strategy is to provide a scalable product ladder built primarily around cameras, guiding the industry from those basic ADS features up to fully eyes-off autonomy.
How did they get so dominant in ADA?
Their IQ family of vision processing chips.
Ah.
These little chips are embedded in literally hundreds of millions of vehicles worldwide, powering things like automatic emergency braking, lane keeping assist, adaptive cruise control. They built an empire on that.
But now they're moving beyond just chips.
Yes, they've expanded strategically. They offer Mobileye Supervision, which is a high-end Level 2+ system, hands-off, eyes-on driving. Then there's Mobileye Chauffeur, their upcoming Level 34 system, aiming for hands-off, eyes-off. And Mobileye Drive, a full Level 4 system for commercial robo-taxi fleets. It's a step-by-step climb.
What's underpinning their technology? What makes it unique?
Two key things, really. First, their mapping technology called RM, Road Experience Management. It's clever. It crowdsources map updates continuously using the cameras already in those millions of cars with Mobileye chips.
So the cars themselves build the map.
Effectively, yes. It creates a constantly fresh global map using low bandwidth data, which is much cheaper and faster than sending out dedicated mapping vehicles like Waymo does.
Interesting. And the second thing?
Their RSS model, Responsibility Sensitive Safety. This is a formal mathematical framework for decision-making. The goal is to make the AV's behavior provably safe, ensuring it cannot cause an accident based on defined rules of the road and physics. It's designed to be transparent, not a black box AI.
So Mobileye's approach is more conservative. Build on ADA's success.
Yes, they focus on commercializing each step, generating significant revenue from ADAS, which then funds the development of the higher levels of autonomy. They compete with NVIDIA, but with a strong vision-centric philosophy and deep, long-standing ties to automakers like VW and BMW.
Okay, one more key enabler, especially relevant given the sensor debate. Luminar Technologies. They're all about LiDAR, right?
All in on LiDAR. Their core bet is that high-performance LiDAR isn't just helpful, it's essential for safe Level 3 and above autonomy. They want to be the industry standard for this critical sensor.
What makes their LiDAR special? There are other LiDAR companies.
Their key technical differentiator is the wavelength they use, 1,550 nanometers. Most competitors use 905 millimeter.
Why does that matter?
1,550 millimeter light is absorbed by the human eye, so it's considered eye-safe even at much higher power levels than 905 millimeter.
And higher power means?
Better performance. Significantly longer detection range, they claim over 200 meters, even for dark, low reflectivity objects like tires on the road, and better performance in bad weather like rain and fog.
Which is critical for highway driving.
Absolutely critical. You need that long range to have enough time to react safely at higher speeds.
Are they just selling the hardware, the sensor?
Primarily the sensor itself, like their Iris series. But they're also developing software, the Sentinel stack, to help automakers integrate that LiDAR data into a full safety or AV solution.
How are they getting automakers to adopt it? LiDAR is still seen as expensive.
Their strategy focuses on securing large volume series production contracts, making LiDAR standard equipment, not an option.
And they've had success with that.
Their biggest win, a landmark deal really, is with Volvo cars. Volvo made Luminar's LiDAR standard, not optional, on their flagship EVs, the EX90 SUV and ES90 sedan.
Standard equipment, that's a big deal.
Huge. It effectively signals that, for Volvo, a brand synonymous with safety, achieving true higher-level autonomy requires LiDAR.
So Luminar isn't just selling a part, they're selling a safety philosophy.
Exactly. That Volvo deal puts enormous pressure on competitors. If you're launching a premium EV aiming for level 3 features, and Volvo says you need LiDAR, it's hard to argue you don't without looking less safe.
So they're trying to shift LiDAR from an expensive option to a baseline requirement, like airbags.
That's the goal. And their success directly challenges Tesla's vision-only approach, providing powerful validation for the multimodal sensor strategy, at least in the premium segment. It really forces automakers to pick a side on the sensor debate.
Okay, we've covered the main developers and the key enablers, but what about the established auto giants? And what's happening in China? That seems like a whole different world.
It's definitely a complex picture. Traditional automakers are navigating this through a mix of in-house R&D and lots of strategic partnerships. And yes, the Chinese AV industry is its own rapidly evolving ecosystem.
Let's start with a traditional player making big moves, Mercedes-Benz.
Right. Mercedes is clearly leveraging its brand, luxury, technology, safety to be a leader here. Their strategy seems focused on being the first to bring a properly certified, consumer-ready, eyes-off system to market.
Certified being the key word.
Absolutely. It's about incremental, rigorously tested, and government-approved progress. Very different from a beta release.
And they achieved that with Drive Pilot.
They did. First, and so far, the only automaker with regulatory approval to sell a certified SAE Level 3 system to the public. It's approved in Germany and also in California and Nevada in the U.S.
On which cars?
Available on their flagship S-Class sedan and the electric EQS.
And it has limitations, right? It doesn't work everywhere.
Very strict limitations, what's called the Operational Design Domain, or ODD. It only works on specific, pre-approved freeways, only during the daytime, in clear weather, only in heavy traffic, and only at speeds below 40 miles per hour.
So basically traffic jams on the highway.
Pretty much. The classic tedious traffic jams scenario.
But within those limits, what can the driver do?
That's the key difference for Level 3. Within that ODD, the driver can legally take their hands off the wheel and their eyes off the road. They can look at the center screen, watch a video, answer emails. The car takes full responsibility.
How do they get it certified? What's the tech stack?
It's a conservative, redundancy-focused approach. Full multimodal sensor suite cameras, radar, and crucially, LiDAR.
They use LiDAR from Luminar.
Yes, supplied by Luminar. The system also needs a connection to an HD map for precise localization and road info, and it's all powered by NVIDIA's compute platform.
So they're relying heavily on partners.
Very much so. Mercedes exemplifies that partnership-heavy model. NVIDIA for compute, Luminar for LiDAR. They even work with a Chinese startup called Momenta to help develop systems specifically for the critical Chinese market.
Why is that approach smart for them?
It lets them integrate cutting-edge tech from specialists and accelerate development without having to bear the massive R&D cost of building everything in-house. They focus on integration and the overall vehicle experience.
And being first with a certified L3 system is a big marketing point.
Huge. It contrasts sharply with the ambiguity around systems marketed as beta. It positions Mercedes as the responsible leader, suggesting that true, legally recognized eyes-off driving requires comprehensive sensors and official government sign-off. It's about guaranteed reliability within limits, not generalized ambition.
Okay, now let's shift focus to China. You said it's a parallel ecosystem.
It really is. You have this powerful group of Chinese tech companies and automakers benefiting from strong government support, a huge domestic market that's very receptive to new tech, and incredibly fast innovation cycles.
And their goal?
To leapfrog the West, essentially, especially in large-scale robotaxi deployment and advanced ADAS for consumers.
Who are the key players there?
In robotaxis, you have Baidu with its Apollo Go service, Pony.ai, AutoX, WeRide. These aren't just small tests. They're deploying large fleets in huge cities like Beijing, Shanghai, Guangzhou, Shenzhen.
How does their scale compare to, say, Waymo?
They're catching up fast and in some ways potentially surpassing. Baidu's Apollo Go, for instance, was reporting ride numbers comparable to Waymo, around 100,000 rides per week, often at a lower cost per mile. They're moving very quickly on deployment.
What technology are they using? Similar to Waymo?
Largely, yes. The dominant approach in China mirrors Waymo and Cruise sensor-rich vehicles with multiple lidars, cameras, radar, navigating using HD maps. There seems to be a strong consensus there that redundancy is essential for safety in their complex urban environments.
And what about systems in consumer cars, like Tesla's FSD?
There's intense competition there, too. A new wave of Chinese automakers, XPeng, NIO, Li Auto, even the electronics company Xiaomi, now are rolling out incredibly advanced ADS systems.
Competing directly with FSD.
Directly. And importantly, these systems are trained and optimized specifically for China's unique driving conditions, the traffic density, the mix of vehicles and pedestrians, the infrastructure. Some argue it's a richer, more challenging training ground.
Are any offering level 3 yet?
Yes, some brands like Zeekr, part of Geely, are already offering level 3 systems for private owners in China, pushing the boundaries for consumer tech.
So what makes the Chinese market so different so fast?
It's not just imitation, it's a distinct ecosystem. A huge factor is the national government making AVs a strategic priority. This means faster regulatory approvals, coordinated investment in infrastructure like 5G for vehicle communication, CV2X, and strong public-private partnerships. It creates a unique home field advantage.
So Western companies can't just show up and sell their tech.
Not easily. They often need to adapt significantly and partner locally. We saw Tesla needing Baidu for mapping data to get FSD approved. Mercedes works with Momenta. It suggests the global AV market might actually split into distinct Western and Chinese spheres of influence, each with its own leaders and standards. It's a fascinating dynamic. So we've looked at all these players, their tech, their strategies. How do we actually figure out who's leading? It's tricky. Simple metrics like test miles or company valuation don't really capture the whole picture.
Right, leadership seems context dependent.
Exactly. We need to assess strategic defensibility, how likely they are to succeed and scale in the long run. And one powerful lens for that is looking at vertical integration.
Meaning, how much of the whole autonomous driving stack a company controls in-house?
Precisely. How much do they build themselves versus relying on partners or suppliers? It reveals a lot about their strategy and potential vulnerabilities.
And looking at that reveals different approaches.
Two fundamentally different paths emerge. You have the deep, almost total vertical integration, like Tesla aims for. And then you have a more partnership-heavy ecosystem approach that most others, including Waymo and the traditional automakers, tend to favor.
What are the key parts of that value chain we should consider?
You'd look at things like AI chip design, sensor hardware, LiDAR, cameras, radar, the core driving software stack, HD mapping capabilities, the data collection and training infrastructure, the vehicle platform itself, and finally, the fleet operations or go-to-market strategy. How many of those boxes does a company tick internally?
So if we score the major players on that, what does it tell us? Is there one clear leader?
Not really. The scorecard makes it clear there's no single undisputed leader across the board. Leadership is definitely bifurcated. It depends which specific race you're talking about.
Okay, let's break that down. Who leads in vertical integration?
Unquestionably, Tesla. They exert or aim to exert direct control over almost every piece. Custom AI chips, FSD chip, Dojo, their own camera designs, the end-to-end neural network software, their global fleet as the data engine, vehicle manufacturing, even direct sales.
What's the upside of controlling everything?
Maximum control over the pace of innovation, the cost structure, the end-user experience. If they solve the core AI problem, they own the whole solution. But the downside must be huge, too.
Immense, colossal capital expenditure needed to build all that capability. And they carry the monumental burden of solving every single complex problem in-house, from silicon physics to obscure driving edge cases. Okay, so Tesla leads on integration. What about Waymo? Where do they lead?
Waymo leads in strategic integration and, critically, in deployed level 4 autonomy. They don't control everything like Tesla, but they have deep vertical integration in the areas most crucial to their competitive advantage.
Like what?
Their core software stack, the design of their proprietary sensor suite, and their massive data and simulation infrastructure, obviously leveraging Google's huge resources there. They integrate where it counts most for their specific robotaxi strategy.
And they partner for other parts?
Exactly. Vehicle manufacturing with Jaguar, Zeekr, Magna, network access through Uber. It's a more capital-efficient approach. It lets them focus their resources on the hardest AI-driving problems while leveraging partners for scale in manufacturing and market access.
And crucially, they are the leader in deployed commercial level 4.
Undisputed. They've proven the core tech works in complex cities and are now focused on the business challenge, scaling commercially and making it profitable. They're actually operating a service and earning revenue today.
What about the enablers? NVIDIA.
NVIDIA is the undisputed leader of the enabling ecosystem. On that scorecard, they dominate the AI chip and core software columns for a huge portion of the industry.
They're not trying to build the whole car or service.
No, their goal is to be the indispensable platform underneath everyone else. They want to be the engine powering a diverse range of autonomous vehicles built by others.
Could that be the most profitable position long term?
It's certainly possible, especially if the market remains fragmented rather than consolidating around one or two winners. NVIDIA potentially wins no matter who wins the car race, as long as they're using NVIDIA inside. It's a very strong strategic position.
So bring it back to Tesla again. If Waymo leads deployed L4, what does Tesla lead?
Tesla is the leader in scalable ADS and data collection. Their strategy of selling that Level 2 system globally gives them that unmatched data flywheel, constantly feeding their AI.
So they have the potential for the largest ultimate scale.
Absolutely. The potential is there for a massive decentralized network if they can make the leap from supervised L2 to truly unsupervised L4 or L5. But they haven't yet proven they can solve those final critical safety challenges for true autonomy.
And they still face headwinds.
Significant regulatory headwinds and public perception challenges because of that public beta model and the controversial marketing. The potential scale is huge, but the proven reliability for full unsupervised autonomy is still the big question mark hanging over them.
Okay, wow. So wrapping up part 1 here, what does this all mean for you, our listener? We've covered a lot of ground in this deep dive into the complex, often confusing world of autonomous driving.
We really have. We've seen that fundamental split in thinking the more is more camp with its focus on sensors and maps, like Waymo.
Versus the human analog AI approach, betting big on vision and data, like Tesla.
We looked at the ambitious strategies of both. Waymo as the leader in deployed robotaxis and Tesla as the visionary scaler with that incredible data engine.
We also saw the cautionary tale of Cruise. A stark reminder that trust and regulation are just as important, maybe more important, than the tech itself.
Absolutely. And we explored the crucial role of the enablers NVIDIA aiming to be the underlying platform, Mobileye evolving from A-Days, Luminar pushing LiDAR as a safety standard.
Plus, how traditional players like Mercedes are adapting through partnerships, and that whole separate, rapidly accelerating ecosystem emerging in China.
Yeah, the Chinese vanguard is definitely a major force to watch.
It feels like the central debate, that core disagreement between LiDAR-heavy, redundant approach and the vision-only, AI-centric philosophy. That's still the big unanswered question, isn't it?
It absolutely is. And the way that plays out will really shape the future of this technology, the cars we ride in, maybe even the cities we live in for decades.
And as we finish up here, it seems clear that the biggest hurdles moving forward aren't purely technological anymore. The tech is getting incredibly capable.
Right. Now, the challenges are increasingly regulatory. How do governments approve these systems? Economic, how do you make them affordable and profitable? And social, how do we as a society adapt to and trust these machines?
So here's a final provocative thought for you to take away from part 1.
Yeah.
Think about how that fundamental strategic choice a company makes, deep vertical integration versus a partnership ecosystem, doesn't just shape its tech.
It ultimately dictates how quickly, how safely, and how affordably this autonomous future actually arrives in your life. Will the robotaxi you hail, or the car you eventually own, be a product of that meticulous, mapped, redundant philosophy, or the result of a generalized AI learning on the fly?
What does that choice mean for your future mobility? Something to chew on.
Definitely. And please join us for part 2 of this deep dive. We'll broaden the lens significantly to explore the really profound long-term impacts of all this. We'll look at personal car ownership, trucking and logistics, urban planning, the economy, how autonomous vehicles could fundamentally reshape your world.
You won't want to miss that. Thanks for diving deep with us today.